Hey everyone, and welcome back to PrepFusion. So today we'll start the lecture 8A of Engineering Mathematics of the first chapter, that is a linear algebra. So in this lecture we'll study about linearly dependent and independent rows and columns. What do they mean? What is their significance? Then we'll understand the solution of non-homogeneous equation. We'll learn about solution of non-homogeneous equation. Then we'll do few questions on that. So what is non-homogeneous equation? And then I will tell you about homogeneous equation, and we will do the solutions of homogeneous equation in the next lecture. Okay, so that is why this is 8A and that will be 8B. So before starting this lecture, I want to say a short note about nullity. So like in the previous lecture I gave you the definition of nullity, so I want to be more precise with that. So here I have also like I skipped a question of nullity over there, so I will do this question. But before doing this question about nullity, I want to give you the definition. I have already told you the definition in the slide, right? I have written it, but I have changed it a bit because I just something came into the mind, is that nullity definition was not precise. It was something different when I researched it, and yeah, it was different because if I can find it, where is it? Where is the nullity definition? Let me get there first. If I can, yeah, here, right? So there I only said that nullity is a number of free variables, or number of free variables. But also I hope I also wrote this, the number of variables minus 9. It is also known as the dimension of null space. Okay, and here nullity means total number of variables, whichever number of variables are there. Like in this format, right, I have x1 x2, so I have two variables. If the rank is 1, then nullity will be 1. Here in the first case the rank was 1 for this case, because this is totally 0 row, so this rank will be 1 only. Okay, so yeah, that is the meaning of nullity. What does nullity means? Nullity means number of free variables. What does free variables mean? In which I am free to choose whatever values. That variable can be chosen as whatever value. So here x2 can be chosen anything. Okay, but x1 will depend on x2. Okay, so x2 can be anything, but x1 depends on x2. So x1 is fixed according to x2, but x2 is free. That's why it is known as the number of free variables. We'll do examples, from there we will understand this. Now, dimension of null space. It is also known as dimension of null space when we'll study about vectors. Okay, there we'll understand about null space. When we'll study about vectors, span, all those things, we'll understand null space. For now, just understand this is also a meaning of nullity. Next is it is the total number of variables minus rank. So what is the total number of variables? Or I wrote there total number of unknowns. So or I can write total number of unknowns. So this is also another formula for nullity. Okay, so yeah, these are the formula for nullity. Okay, actually before going to the question, let me quickly summarize whatever we learned in this lecture 7, right, previous lecture. So basically we learned about the rank. So rank is the number of non-zero rows in the row echelon format. Also we learned new definitions about rank. Basically the number of independent rows and columns is also known as the rank. Okay, or the maximum order of the minor, which is non-zero. That is also the minor method, right, that we already learned. Okay, and nullity I already told you. Now then we'll found out the rank from this. Okay, we have to first convert it into row echelon format, and then we can find the rank with this method, right, row echelon method, number of non-zero rows. Okay, so yeah, we got the staircase method, all those things. So next is I summarized what row elementary transformations are and what we can do, what changes, what things, right. So determinant remains same unless and until we are doing this. We are multiplying a scalar with a row, then determinant changes, but the matrix obviously will change, but obviously the rank remains same. In all these cases rank will remain same. Okay, for column elementary transformation also same only, similar cases only. Okay, so then I told you, like here also the number of linearly dependent rows and columns are also known as rank. Okay, we'll obviously do more questions on this, okay, today. And here also this is also another definition, the highest order of the non-zero minor, also known as the rank. Okay, so yeah, I just gave you a definition, but before like saying all this, right, I should have said you about the submatrix. So the submatrix is basically obtained by deleting some rows and columns. Okay, so if I delete some rows and columns, I get submatrix, and square submatrix are the number of rows and columns are equal of the submatrix. So these are also known as the minus. Basically these are known as the minus. Okay, so these are the minus, and all of the determinants of the minor should be non-zero. Then only whichever highest order of the minor has non-zero determinant, that will decide the rank of the matrix. So we solved few examples, right? We solved few examples here. Now obviously this is a rectangular matrix, so it doesn't have a determinant. But what is the highest order minor? Highest order minor is 2 cross 2, the minimum of rows and columns. So 2 cross 2 minus, I've written it down, and I can see. Then I checked for it, right? Then I told you the formula, like this is just simply permutation combination. I won't explain it much over here. Now I told you to find the rank. Okay, we can write all the minors, and what I can see, all the minors has determinant equals to 0. Even if one minor has non-zero minor, okay, so non-zero, even if one minor was non-zero, then the rank will be equal to 2. But all the minors of 2 cross 2 are equal to 0, then rank can't be equal to 2. It has to be something lower than that. It has to be equal to something lower than that. So rank will be equal to 1. Why? Because all the elements are non-zero. Even if all the elements were 0 over here, then only rank can be 0, else it cannot be equal to 0. Even if one element is non-zero, then rank will be always equal to 1. Okay, so yeah, that is one thing. Then we did few more examples just to understand the concept of rank with the minor method. Okay, so it took a lot of time. Now I told you the properties of rank. Basically, elementary operations do not change the rank, which you already saw, right? And then all these things, the rank of identity matrix is n, because all of the columns and rows are linearly independent, because 1 times 2, can I get row 2 in terms of row 3 and row 4? No, I can never be able to get that. They are always linearly independent, which you will obviously learn in this lecture also. Okay, and rank of scalar matrix is n. Basically, these are scalar only. Just multiply scalar with this and becomes a scalar matrix. So rank is because I'm just scaling, right? It won't change the rank. Again, rank of a non-singular matrix is n because it is a full rank matrix. So all these are properties we learned. Okay, I won't go much into details. I proved a few things to you, and then we did a few questions on that. Okay, so basically we'll do the question that I just was at the end of this lecture, right? So let's start that. So I have a matrix A 6 cross 3 is a non-null matrix. What does non-null means? Non-null means it is not as like null matrix. That means its rank cannot be 0. Only null matrix has its rank equals to 0. Even if one element is non-zero, then its rank cannot be equals to 0. All elements have to be 0. So non-null means its rank cannot be equals to 0. And they are asking about the nullity of A. Can be, okay, can be. So there are many options over here. So this is a MSQ. I should have written it over here. This is a MSQ. Okay, so non-null means the rank of A has to be greater than 0. It can't be equals to 0. Okay, and now this is A 6 cross 3, right? So what can be the maximum value of rank? The maximum value of rank will be minimum of 3, 6. Okay, the maximum value of rank will be minimum of 3, 6. So basically here it will be 3. It will be 3. So let me go back to here. So rank of A has to be less than maximum of, obviously I won't be able to tell the exact values because I obviously don't know the what do you say, elements, right? I obviously don't know the elements. So yeah, rank of A is maximum of, sorry, not maximum, minimum of 3,6, right? So it is minimum of 3,6. So obviously what is my range of my rank? So range of my rank is 3, 1. Okay, so okay, it can be also equals to this, right? And obviously it can't be equal to 0, but it can be equals to 1, right? So this is my basically range of my rank. Now what is the definition of nullity? So nullity definition, we just learned about that. Nullity is number of variables minus rank of A. So here how many number of variables are there? So if I have, they are saying there are 3 columns. So if there are 3 columns, that means they are arranging their variables in column format, right? We generally used to arrange like that only. So this is 6 cross 3, right? 6 cross 3. So this will be x1, x2 and x3. So 3 variables, right? 3 variables, and rank is this varying between this range. So my NA equals to 3 minus rank of A. Okay, 3 minus rank of A. So if it is equal to 3 minus rank of A, then what does this mean? This means that so my NA can vary from what? So NA can vary. Let me just put this thing here. So rank of A will be equals to 3 minus NA. Now rank of A is varying from 1, 3 minus NA to 3. So NA can vary. So if I take the NA this side and 1 this side, so NA has to be less than 2, NA has to be less than equals to 2. And if I take this NA this side and 3 this side, this will be 0. So NA has to be greater than 0. NA has to be greater than 0. Okay, so this is the range for our nullity. This is the range for our nullity. So basically here, which options satisfy? So it has to be less than 2. Okay, it has to be, sorry, it has to be less than 0. I think I forgot the options actually. So I framed the options wrong. So here, right, so I have to change the option. I'm really sorry for that. So okay, these are fine. So let me change few of them. Like I forgot about the option framing, right? So maybe I would have framed according to the rank. So yeah, let me make this 2. Okay, so yeah, I'm sorry. So according to the options, it can be between 0 to 2. It can also lie, it can be so 0 also, 2 also. So 2 is in the option, so 2 will be our answer, 2 will be our answer, and 1 will be our answer. Okay, these two are lying within the range. Okay, so this is how you solve a nullity question. Okay, so let me take an example, and from there we will understand this better. Nullity example, right? So here, let me take a 6 cross 3 matrix. Okay, 6 cross 3 matrix I have taken, and this is 1 0 0, which has obviously valid solutions, 0 0 1. Okay, and I am only talking about the rank, right? Only talking about the rank. So this is 1 2 3. Okay, 3 2 4. Okay, and this is like 1 1 1, and this will be, so this will be 6, this will be 5 9. Okay, so yeah, now basically what do you observe? So with this 3, right, these 3 rows, you can obviously make a linear combination of these rows. So basically I can write my row 5, as a linear combination, row 5 as a linear combination of 1 times row 1 plus 2 times row 2 plus 3 times row 3. Okay, it is a linear combination. And my row 6 is a linear combination of 3 times row 1 plus 2 times row 2 plus 4 times row 3. Okay, 4 times row 3. So basically it is linear combination. If I just simply do the linear combination, subtract these two rows, right, all of this will become 0, and if all of them will become 0, then my rank will be 3 only, the number of non-zero rows in row echelon format. So I have only 3, so rank is 3. In this case, rank is 3. Now can you tell about the nullity? So what did I tell you about nullity? Nullity is the number of free variables. Now, as here my x1 has to be this is x1, right? This is x1, x2, x3. So it is saying the first row is saying x1 equals to 1, x2 equals to 1, x3 equals to 1. So there are no free variables here. Variables. Okay, I don't have any choice that I can choose x3 anything. Okay, I don't have any choice. Even if you, I have chosen here very simpler numbers, 1 0 0 0 1 0 0 0 1. Even if you choose something else, okay, then I can always reproduce these two rows with the help of these 3 rows. Okay, I can always do that. Okay, that's why the rank at max can be 3 here. Okay, at max can be 3, because I need 3 variables to define 3D space, right? To define 3D space, and these 3, if these 3 cover these 3 spaces, right, x, y, and z, then obviously I will be able to cover these 3. Okay, cover these 2 rows. Okay, because these are obviously lying on the same space. Okay, if you don't understand anything, don't worry, we will learn about this eigenvectors and eigenvalue later on. Okay, don't worry, not about eigenvectors, we will learn about vector span, vector space, all this later. Okay, don't worry, I just people who know, they may like understand this what I am talking about. So yeah, the rank is 3, so nullity here is 0, because I don't have any free variables, no free variables. Okay, here when was nullity 0? Nullity was 0 or rank was 3. This rank was 3, nullity was 0. Yes, hence proof, right? Now let's do next example. Let's do another example. From there also we will understand. Let's say if rank is 2. What if rank is 2? Now if rank is 2, simply these will be all zeros, right? This will be all zeros. Okay, now obviously I won't be able to reproduce this, right? I have to change this. So I need rank 2, right? I need rank 2. Okay, so you might say, sir, here rank can be 4, right? These two are non-zero. No, if you do one thing with the combination of these three, you will always be able to produce this. You will always be able to produce this. A combination of these three will produce this. Okay, so yeah, rank will be anyways 3 here. Okay, so just for a simplicity, what I will do is for this the rank is 3, but I will change this to uh, something else. What I will do is I will simply make this 0 and also make this 0. Okay, again these three, right? These three are linearly dependent. I will talk about linearly dependent and independent in the next section, just after a few of the slides, but I hope you are understanding it. Linear means power 1, and dependent means they can be written in some relation with the this previous two rows, right? So these three are the linearly dependent rows, and these two are the linearly independent rows. Okay, so yeah, so this is the case. So as these two are linearly independent, that is rank is also defined as this, that I will just say rank equals to number of linearly independent rows, which is 2. Okay, or you can see the number of non-zero rows in row echelon format, which is 2. This can be made 0 with the combination. Okay, as I showed here, right? This can be simply made 0 with the combination if I do the linear operations, right? So rank is 2. Then what will be the nullity? Nullity is number of variables minus rank. So 3 minus 2, which is 1. So is the nullity 1 here? Yes, because these will be converted to 0. Hence my x3 is a free variable here, because 0 times x3 is equals to, okay, I made a mistake over here. This will also be 0. Sorry, else we will have no solution. So sorry, this is 0. So 0 times x3 is equals to 0, which is always true. Always true. Always true. Okay, so if this is always true, then x3 I can choose anything I can choose x3. So x3 I can choose as alpha. X3 equals to alpha, and my, okay, I made a mistake over here, slight mistake. Okay, x2 is obviously fixed here. X2 equals to 1 and x1 equals to 1. So these two are fixed and this is free. So this is free and these two are fixed, right? So these two are fixed. Okay, so yeah, this is basically a small example I want to take. Now let's actually start our lecture. This was from the previous lecture. Let's start our lecture. So as I told, right, rank can also be defined as the number of linearly independent rows or number of linearly independent columns, whichever one will be correct. So here, as you can see, you can also do it from columns also. Okay, you can do it in terms of columns also. So yeah, the number of linearly independent rows and columns will always be same. The number will be always same. Okay, so you can check like what columns are independent over here, and you can do it for yourself, right? So that is what the definition of rank is. Another definition of rank. So here let's solve few questions and do few examples. So basically we have to find the rank of the following matrices. So this is a matrix. So here what we can do, so are there any linear dependency between these two? So here first of all I can see this is a 2 cross 3 matrix. Okay, so rank will be obviously less than 2. Okay, rank at max can be 2. Rank at max can be 2. Are the two rows linearly dependent? Okay, they are not. Even if you convert it into row echelon format, you will see. So it is like okay, this is 1 2 3. So what I can do is I can simply multiply, okay, 1 by half and 0 I can do. Okay, so basically we can see the rows are linear, two rows are linearly independent, right? So rows are linearly independent. Rows are linearly independent. So obviously rank will be 2 over here. I can say rank of A will be 2. But let's see it from column point of view. So if I see it from column point of view, what I can do, I can like try to make all zeros, right? I can try to make all zeros. So if I multiply 2 and then subtract, and multiply 3 then subtract, what I will get? I'm multiplying 0, this will be 0, this will be 4 only, this will not change, and this will be 0 and this will not change, right? This will not change. Now further what can I do? Okay, so here further what can I do? So what did I do here? So for this is like A case, this is B case. So this operation, what did I do? I just simply did column operation. So I changed C2 to C2 minus to C1 and C3 to C3 minus 3 C1. Okay, so basically then what I can do, I can totally make this column 0. Okay, how? Basically I will subtract 5 by 4 C2 from this column, right? C3. So I will do C3 is changed to C3 minus 5 by 4 C2. Okay, 5 by 4 C2. Okay, so this is totally 0. Now if this is totally 0, what does it mean? If this is totally 0, what does it mean? So this means that I have two independent columns and like two non-zero columns, and other one is 0. So two non-zero columns. So two non-zero columns which are linearly independent, right? Because here these are not proportional, obviously. Okay, no combination can make this proportional. So non-zero columns which are linearly independent, two non-zero linearly independent columns. Okay, so here obviously my rank will be from this, as this is 2, so rank will be 2. So you go from column, you go from row, it doesn't matter, you will get the same answer. So I should write here number of non-zero linearly independent rows and columns. So this is also another definition, non-zero. Okay, so let me copy this. So these two are talking about the same thing only. These two are talking about the same thing only. Okay, so yeah, rank is 2 either way. Now let's solve this second one both ways, right? Let's solve it first with the column way. So if I want to solve it with the column way, what I will try to do, I will try to make this 0. Okay, I have only two columns, so either I can make only one thing 0, right? So if I do C2 change to C2 minus to C1, this will be 1 0 4 minus 3 3 2. Hence obviously my rank of A will be 2 because I have two independent columns. Now let's solve it using the row method. Okay, using row method. If I solve it using the row, so what I will do, I will try to make this 0 and this 0. Okay, so what I will do, I will do R2 change to R2 minus 4R1 and R3 change to R3 minus 3R1. Okay, so this will be changed to something like this. I'm just doing this in rough because this is anyways pretty easy for you. So 8 minus 3, and this is 3, this is 0, so this is 2. Okay, so now what I can do, I can simply make one of them 0, right? Again the same procedure what I was following previously. So let me make this rank here. So this will be equals to 1 2, then I should write this as similar trans equivalent, right? We're doing equivalent matrix. Forgot to do one thing, that yeah, this is not equal, this is equivalent. So this is going to minus 3 and this is going to 0. How? Basically R3 is changed to R3 plus 2 by 3 R2. Okay, so 2 by 3 R2. So this is how you make it 0. Now I can see right, there are two independent rows. So if I have two independent rows, obviously my rank will be 2. Two independent non-zero rows. Okay, so this is very simple. Now nothing to stress about it here. So pretty simple, right? Pretty simple. So like any other way you can see this. Any other way you can see this. So any other way, what you can say is, so what do you mean by independence? So here, if I take this matrix again, okay, if I take this matrix again, now what do you mean by independent columns? Linearly dependent or independent columns. So if C3, we are saying that C3 is linearly dependent. C3 is linearly dependent. What do you mean by this? Linearly dependent. So if this statement is given, that means we can write some combination of C1 and C2, okay, some linear combination of C1 and C2, okay, which is equals to C3. So this is lambda 1 times C1 and lambda 2 times C2. These are all linear because the power is 1 over here. So if I can write some linear combination of C1 and C2 to express C3. C3 can be expressed in terms of C1 and C2. Okay. So can I find the values? Can I find the values? So I'll just solve for this one, and anything, all the others you can do it for yourself, right? So here we can take each rows, right? Each rows. So first row, what I can say, first row is basically first row of C3 is 3 only. 3 equals to lambda 1 times C1, which is 1 only. So lambda 1 is 1 into 1 plus lambda 2 times C2, which is 2. So 2 lambda 2. Okay. So lambda 1 plus 2 lambda 2 equals to 3. Lambda 1 plus 2 lambda 2 equals to 3. Okay. So next I need to find another variable, another equation. So another equation is through the second row. So second row C3 is 5. Now 0 into lambda 1 plus 4 into lambda 2 equals to 5. So lambda 2 equals to 5 by 4 and lambda 1 equals to, if I put 5 by 4 over here, this will be 5 by 2 and this will go over there, this will be 2.5. So this will be 5 by 2 again. Is it? No, this will be 1 by 2. Sorry, this will be 1 by 2 again, right? So basically I can write that C3 equals to 1 by 2 C1 plus 5 by 4 C2. Okay. So C3 is dependent column and C1 and C2 are independent. Okay, C1 and C2 are independent. So okay, so can I write the other way around? Mathematically we can. C1 is equals to, if I want to write C1 in terms of C3 and C4, C3 and C2, we can. Okay, mathematically we can. Mathematically true. So C1 will be equals to, if I cross multiply 2 on both sides, C3 minus 5 by 2 C2. Okay, so this is mathematically true. Mathematically true. Okay, always true, but we can't conclude about dependency independency, right? Don't conclude anything, but don't conclude about dependence, because we are messing up with the equations, right? We are messing up with the equations, so don't do that. Okay, so yeah, this is basically about the linear dependency and independency. So let's solve this question. So here it is telling which of the options is or are correct. Okay, so A has three linear independent rows. So A has three linear independent rows. It is telling, so A is this, and you have to tell whether it has how many independent rows or how many dependent rows or columns. Okay, so can we conclude anything from here? Can we conclude anything from here? So what I am observing is, if I multiply 2 with this, then add with this, yeah. So basically what I can, so you have to have good observation power. If you don't have a good observation power, what you can say is, if you find the determinant of this, sorry for the burp actually. So if you find the determinant of this, what you'll see, you will get the determinant as 0. Determinant is equals to 0. So if determinant is equals to 0, that means rank cannot be equals to 3. It can't be a full rank matrix, because if determinant is 0, definitely there is some dependency between the rows. Then only determinant can be 0, right? Because one column has to be, one row or column has to be totally 0, right? So basically there has to be some dependency. So that's why rank is that's why determinant is 0. Determinant is 0, rank is less than this 3. Hence obviously rank then there is some dependency, right? So then you have to think, how, what is the dependency? Either you can follow this method, the lambda 1 lambda 2, if you are not able to figure out anything, you have to follow this method. Okay, but generally they give you easier observations. So with observation you can find out. So here what I am observing is, always try to equate one of the elements. Always try to equate one of the elements, and other elements will be automatically equated. So here I was trying to equate 4. So how can I equate 4 with these two, right? These two. So if I multiply 2, these can be equated, but these are not equal. So definitely these are not proportional to each other. So I have to take into account this second row also. Now if I multiply 2 with this, then add these two, what do I see? I get 4. Okay, good, good. Now if I multiply 2 with this whole row, this is minus 2, and add these 3. 3 minus 2 is 1. Okay, again, good, right? That means the third element also will be same most cases, but let's check again. Multiply 2 with this, then I add this is 9. So again, this is good, right? So hence I can see the relationship. Okay, again, relationship has came up, which is a very dangerous thing. So but we have to deal with it. So R3 equals to R1 plus 2 R2. Okay, so they are dependent. So hence dependent. Okay, so this is sure that like there are at least one linearly dependent rows, and like if there is one linear dependent row, then there will be also one linear dependent column also. Okay, column also, because this is square matrix, right? So next, basically, are these two rows equal dependent? So when there are only two rows, right, they have to be proportional to be linearly dependent, because r1 has to be some lambda times r2, or r2 has to be some lambda times r1. So they have to be linearly proportional. They are not in linear combination, proportional. So are these two proportional? If I multiply 2 with this is 2, fine, but this is minus 2, which is not equals to 3. So they are not proportional. So hence they are gone. So these two are linearly independent. So the second option, A has linearly independent rows, two linear independent rows, which is correct. And the fourth option is A has one linearly dependent column. Okay, so uh, if you do one thing, how can we equate this? So basically what you can do is, how can we do this? So this, if I subtract with this will be 2, this will be 3, this will be, so we have to find out some values. So let's find out the column dependency. This is the last one that I will do. Okay, so basically let me write c3, anything I can write c3 in terms of lambda 1 times c1 plus again lambda 2 times c2. Okay, so here let's take the first thing. So if I take the first thing, so 5 equals to lambda 1 times c1, which is equals to 2, plus lambda 2 times c2, which is equals to 3 lambda 2. Then if I choose this, right, if I choose this 1 minus 1, so lambda 1, no, this is 1, right, lambda 1 minus lambda 2 equals to 2 itself. Now if I add these two, what do I get? This is So this is simply equals to 3 lambda 1 plus 2 lambda 2 equals to 7. Okay, I need to cancel one. Sorry. So basically if I multiply 2 with this, 2 lambda 1 minus 2 lambda 2, then if I subtract, this will be 2, this will 5 lambda 2. So lambda 2 equals to 1 by 5. Okay, so subtract this and 5, this is 1. Yeah, lambda 2 is equals to 1 by 5. So lambda 2 is equals to 1 by 5. So lambda 1 equals to 2 plus 1 by 5, which is 11 by 5. Now let's cross verify this, right? We have still the third row left. So if I use this is the first row, this is the row 1, this is the row 2. Okay, just doing this in bit rough. Let's do it for row 3. Let's do it for row 3 and cross verify, put the values of lambda and whether it's satisfied or not. So here third row, right? So 4 lambda 1 plus lambda 2. So 4 lambda 1 plus lambda 2 should be equals to 9. So 9 equals to 4 into 11 by 5 plus 1 by 5. So which is 45 by 5, 9, which is equals to, so 9 equals to 9. So which is satisfying, right? So hence we can check that these are the coefficients, right? These are the linear dependencies. So obviously this, right, you won't be able to do it with observation. 1 by 5 and in 1 5, how will you understand? This is very difficult, right? That's why you either do it through rows or columns. So one of them you find out and you will check that the other one, the column relation will be valid. So if there are two linearly independent rows, then how many dependent rows are there? 1. So number of linearly dependent columns will be also 1 here. Okay, so this is 1. So these two are true over here. What do you mean by this is I should say is how many number of linearly independent rows are there? 2. So number of linearly independent columns will also be 2. Now it will depend that how many columns are there, total columns are there. So if I subtract linearly independent columns from total columns, then I will get my linearly dependent columns. Okay, so don't get confused. Sorry, number of linearly independent rows are 2, then number of linearly independent columns will also be 2. Okay, and from that relation you will be able to find number of linearly dependent columns. In this case, as number of rows and columns are same, hence it will be 1 only. Okay, so it is 1. Now let's do it for this equation. So here, which of the following options is / are true? So here A has 3 or dependency or independency it is talking about, right? So this is the A matrix. So let's find one thing. So again, right, if I multiply 2 with this and add these two, what do we get? Again I get 4, I get 1, I get 9, and again I get 5. So again this row is dependent on these two. So again R3 equals to R1 plus 2 R2. Now obviously there are how many? 2 linearly independent rows. This is dependent, not independent. So just be careful while taking the options. Okay, you might be confused. There are 3 linearly independent rows. No, this is wrong. This is wrong. This is wrong. A has 3 linearly independent columns. Is this true? No. A has 2 linearly independent columns because A's rank is 2, right? So at max it can be 2. It cannot be 3 because rank definition is number of linearly independent columns or number of linearly independent rows. Homework for you is just as I found out from here, you found out. Okay, you found out how many dependencies are there. How many can you write the linear combination of these two, right? So A has 3 linearly independent columns. This is also wrong. A has 2 linearly dependent columns. This is 2 because A has 2 linearly independent columns, and what are the remaining columns left? 2, because total common number of columns is 4. 4 minus 2 is 2. Hence there will be 2 linearly dependent columns. Okay, so this last option is correct. Okay, so I hope this thing got clear from your mind, right? So yeah, let's go to the next question basically. So the rank of 6 cross 7 matrix is 5. Then which of the following statements is true? So rank is 5. So number of linearly independent columns 5. Number of linearly independent rows 5. Okay, so A has 5 linearly independent rows and 5 linearly independent columns, which is correct. Okay, basically the definition of rank. Now A has 1 linearly dependent rows and 2 linearly dependent columns. Now if it has 5 linearly independent columns, then the other two, the remaining, how many remaining are there? 2 columns. So those two will be linearly dependent. So this part is correct. This part, it has 6 rows and 5 of them are linearly independent, so other one will obviously linearly dependent. So this one again is correct. So for C, B is equals to A into A transpose, then B is a full rank matrix. So what is the order of B? So the order of B is, if I check for the order of B, right? So B equals to A transpose. So A is 6 cross 7 and this is 7 cross 6, right? 7 cross 6. So this order will be, overall B's order will be 6 cross 6. Okay. Now what does full rank mean? Full rank means rank is equals to full rank means rank is equals to order. Which is it 2? Is it 2 over here? No, it cannot be, because what we know the rank of B, if it is a product of two matrices, it has to be equals to rank of B transpose. It has to be equals to minimum of rank of A into A transpose, because B is product of two matrices which is A and A transpose. Okay, it has to be minimum of these two. Now if it has to be minimum of these two, which is like for our case rank of A is 5, rank of A transpose will also be 5, so rank of B will be also 5. Okay, rank of B will also be 5, but it is saying it has to be equals to order of the matrix which is 6, so hence this option is also incorrect. This option is also incorrect. Okay, so C is not the correct option. Let's go for the D option. So if I go for the D option, so C is equals to A transpose A, then C is a invertible matrix. Again, this is the same thing, minimum of A transpose A. So C has rank of 5, but its order is 6. Okay, so rank is n minus 1. It can't be invertible because its determinant will obviously be 0. So its inverse doesn't exist. Okay, so inverse doesn't exist. So B, C and D will be wrong here. Okay, so yeah, let's start with this main topic, basically the system of linear equations. So here I have two equations. One is homogeneous equation, one is non-homogeneous equation, right? So basically, what does homogeneous equations mean? Homogeneous equation mean where the right hand side, the constant part, right? Constant part is always 0. All of the variables are 0. Homogeneous means all of them have same power, right? Same power. So homogeneous, that's why. So a1, x1, b1, y1 plus c1, z, all these three equations, all the right hand side will be 0. Okay, why these are useful, I will say you when we will do one example. From there we will understand that why these are also very useful to us. Okay, these are basically useful to solve the non-homogeneous equation. One part of the non-homogeneous equation can be solved through this homogeneous equation. So you know, right? So whenever you make things 0, it becomes simpler. So we first try to solve simpler things, then we tackle complex problems. So differential equation, we first try to solve the complementary function, then we solve the particular integral, right? Particular integral. So pi and cf, if you recall correctly, particular solution and complementary solution. So if you are recalling, like in your 11 12 days, all those 6, we obviously learn those here also, don't worry. So yeah, but in the non-homogeneous equation, the right hand side, at least one of them has to be non-zero. If all of them are 0, then obviously it will come into the category of homogeneous equation. At least if one of these constant parts right hand side are non-zero, then it will be called a non-homogeneous matrix. Okay, so d1 d2 and d3 should not be all 0 simultaneously. Okay, so basically let's do an example. So here, can you tell me what is this set of linear equation, is system of linear equation is called? This is called a system of homogeneous equation. So this is called a system of homogeneous equation. I will just copy this because I am shortcut. So let me paste this. I will take the shortcut. Basically, this is system of homogeneous equation, because right hand side is always 0, right? Right hand side is always 0, so hence this is a system of homogeneous equation. And in this case, as we can see that here at least one element is non-zero, hence this will not be a homogeneous equation anymore. This will be a non-homogeneous equation. So this is called a system of non-homogeneous equation. Okay, so basically let's talk about the solution of system of linear equations. So the solution of system of linear equations can be of three types. One is no solution, one is infinite solution, and one is unique solution. Now here infinite solution and unique solution are called consistent, and no solution is called inconsistent. Basically we have already learned this many times before, so I will not explain this in brief. Okay, basically no solution, they will not intersect ever. They will be always parallel to each other and they will not meet. Infinite means they will always meet. Okay, they are overlapping each other. And unique means they are crossing at one point exactly. They are crossing. Okay, now let's understand a bit about matrix mapping, and from there we'll understand the how to find the solution of homogeneous equations. Okay, so basically we have to understand the matrix mapping, which I've already told you. Basically we'll do the column matrix mapping. Okay, but there are also different types of mapping. So how we used to map, if you recall correctly, we used to map in the column format. So basically what we used to write was, this will be a1, a2, a3. These are the coefficients of x. Okay, and x is written over here. This is plus b, this is b1, b2, b3, and y plus c1, c2, c3, and z. Okay, and this is obviously d1, d2, d3. Now this is called the matrix mapping, which I have already done previously, right? Which I have already done previously when we were doing the vector interpretation, right? So basically which are valid matrix mapping and which are not valid matrix mapping. So here what we can see is that what we could have written over here, we could have written all this in the single format, right? So basically what we could have done is we could have written this in a single matrix. So this I could write a1, a2, a3, b1, b2, b3, c1, c2, c3. This is generally what you do. This is x, y, z, and this is equals to the d vector, right? So this is what we do, right? So I will not write over here. I'm just showing you the example. Now this is the same thing that we have written over here. Okay, same thing that we written over here. So this is known as the row interpretation, or like you can say I'm writing with in terms of columns. So this is row interpretation. Now here what do you see? This is a2, b2, c2, and a1, b1, c1. So is this valid? Is this valid matrix mapping? Tell me. Okay, so you might say, sir, but it was a1, b1, c1, but it interchanged, right? The rows got interchanged. This is valid. Okay, even if the rows are interchanged, this is valid. So this is also valid even though the rows are interchanged, because it doesn't matter, because okay, one thing is invalid over here. This d1 has to, d2 has to go over, d1 has to go down. So yeah, it wouldn't have been valid if d1 was still up here. So if I'm swiping these two rows, all of the elements has to swipe. All of the elements have to swipe over it. Okay, these two don't have to swipe. Okay, these don't have to swipe, but these, right, these have to swipe, because a2x plus b2y plus c2z equals to d2. This is the actual equation, right? So in the end, how do we understand which is valid or not? Basically when we write this, right, when we equate the left hand side and right hand side, we should get these equations. That is how simply we get the valid matrix mapping, right? So yeah, these two you have to move. Now let's go to the third one. So here this is also a valid matrix mapping. So what I am doing, I am just taking the transpose of this whole equation. If I take this transpose of this whole equation, okay, what will happen? So this transpose will come inside, this transpose will come inside, they will swipe their places. So if I do the transpose of a column matrix, it will become a row matrix. So that is basically exactly what has happened, x, y, z. And if I do this transpose, basically the columns become rows and rows becomes columns. So that is exactly what has happened. And obviously I am doing the transpose of the right hand side, right? Right hand side constant part also. So this also become d1, d2, d3. Okay, so yeah, this is basically a valid matrix mapping. So these are also valid matrix mapping, but here you have to be careful. I have also swapped the two columns. I can't swap two rows here. I can't swap the two rows here. I can't swap the two columns. If I swap the two columns, then I have to swap these variables. Just be careful, right? So don't think about all this. So whatever operation you do, okay, the final equation should be same. Okay, that's a simple funda. So you do any operation, but the final equation should remain same. This, right? We should get back our equation. If you are not getting back our equation from any of this matrix mapping or operation, then we have done something wrong. Okay, simple funda is this. So if you are swapping these two columns, right? You have swapped these two columns, then obviously you swap these two columns. Okay, so yeah, that is basically this. Now here what I have done, I swap these two columns. So if I have swapped these two columns, what is this equation telling us? this equation is telling us that b1x into a1y into c1z equals to d1. Is this true? No, this is not true. Okay, so this is not true, hence, because it was a1x not b1x, so this is not true. Next, what I have done, I have swapped the two rows of this thing, right? Two rows. So if I swap these two rows, this, what is this thing? X1 into b1 y, sorry, x into b1 y into a1 z into c1. Again, this is telling me wrong. So if I swap these two, then it can be correct. So this is y into b1, then x into a1 z into c1. But what will happen is these two rows I swap, right? Then this, yeah, what will it will be valid. So obviously if I swap these rows, we have to swap these two. So that is the main thing, that at the end you should get the same equation. That is the concept that I want to give it to you, right? So here let's do one question. So here it is saying which of the following are valid matrix mapping for the system of linear equation. So here x plus y equals to 3x minus 2y equals to 5. So x plus y coefficient is 1 1 and 3 minus 2. 1 1 3 minus 2 correct, and this is in the column format, correct, x y. So x plus y equals to 2 correct. 3x minus 2y equals to 5. Yeah, this is correct. So this first one is valid. First one is valid. Now this one, right? 3x minus 2y equals to 2. Is this correct? No, this is not correct, right? So x plus y equals to 5. Again, this is not correct because we have swapped these two, but we haven't swapped these two. If we would have swapped these two, then this would have been correct only. So this is wrong. This is wrong. Okay. Let's go in the third option. So this is in the basically row format. So here what I can do, x plus y equals to 2, correct. 3x plus minus 2y equals to 5. Okay, again this is correct. So this is correct only. This is in the row format. Now here 3x minus 2y equals to 2. Is this correct? 3x minus 2y equals to 5, not 2. Again, right, I have swapped these two columns, but I have forgotten to swap these two, right? So if I have forgotten to swap these two, obviously it will be invalid again. It is invalid matrix mapping, right? Invalid matrix mapping. So let me mark this in red. So basically let's now come to the non-homogeneous equation. So we already know this. Okay, still I am summarizing this a bit, that how do we define non-homogeneous equation. So basically non-homogeneous equation, here I have already written that A is the coefficient matrix and the augmented matrix is A semicolon B. So basically for a non-homogeneous equation, the equation is written something like this, that Ax equals to B matrix, the constant part, where B is not equals to 0. So B is not equals to 0, right? B is not equals to 0. So basically A is the coefficient matrix and B is not equal to 0. So what cases can happen here? What things can happen? So if I have the augmented matrix, now two things can happen. Either the rank of the coefficient matrix and the augmented matrix are not same. If they are not equal, then only we can directly conclude that there is no solution. Directly conclude that there is no solution. Okay. Now, if the rank of A is equal to the augmented matrix, then there are two cases. If the rank of A equals to the augmented matrix equals to the number of unknowns, then it will have a unique solution. Simply you can see number of equations is 3, number of equations is 3, and number of variables are 3, hence its unique solution. You can relate like that. The rank of A is equals to rank of A semicolon B, which is the augmented matrix, hence which also is equals to the number of unknowns, then we will directly fall into the unique solution. And this is also called as the trivial solution, because this is the boring solution, because unique solution, yeah, only one solution, right? Boring solution. That's why this is known as trivial. Okay, you can remember it like this, because this is all terminology. So you have to remember the terminologies as well, the names as well. Okay, so unique solution. Next is rank of A is equals to rank of A semicolon B. If rank of A is equals to rank of A semicolon B, which is less than the number of unknown variables, then what will happen? We'll get infinite number of solutions. Okay, it can be anything, but if it is less than the number of unknowns, we get infinite number of solutions, which is also known as the non-trivial solution, because it is not boring. It can be anything, right? Anything. So that's why it is non-trivial. We'll do examples from there, we will understand. But how can we sure conclude that it will have unique solution? How can we sure conclude? So we can't. Basically, we have to check both, right? So if it but one thing we can say, if the determinant is equals to 0, okay, if the determinant of A, so here I can write that in this case, right, in the no solution case, determinant of A is equals to 0 as rank of A is not equals to rank of B, and if it is not equals to rank of B, right, then it has to be something less than that, something less than that, because if rank at max, what can rank of AB be? At max, rank of AB can be the order of this n. Okay, let's say n, and here it is saying it is not equals to the rank of AB. So if it is not equals to the rank of AB, obviously it can't be n plus 1, right? It can't be more than the this n plus 1. It has to be something less. If it is not equal to that, it can't be n. It can't be n plus 1. So obviously it has to be something less. It will be n minus 1. If rank is n minus 1, that means there is one linearly dependent column or row. Hence that means the determinant will be 0. Okay, so if determinant is 0, it can be no solution. Now if determinant is 0, it can be infinite solution as well, because rank of A equals to rank of AB, that is fine, but it is less than the number of unknowns, number of variables. If it is less than number of variables, obviously we have n variables, n is the number of variables. So if you have n variables, then basically the determinant will be 0, because it is less, right? It's saying it is less. So let me check if it is recording or not, else I will destroy it, right? Yeah, it is recording, and it is recording, fine. So here also, in this case also, the determinant is 0. Okay, but only in this case, because these two are equal and this is equals to number of unknown variables, that means it is equals to n. So if it is a full rank matrix, that means here determinant of A will be non-zero. So if determinant of A is non-zero, so for sure short, so what can I summarize from this? So if determinant of A is not equal to 0, then I can surely say unique solution. Unique solution. Now this is the first case. Now what about the second case? So if determinant of A is equals to 0, it can be two cases, right? There can be two cases. I cannot sure say, I have to check the rank of AB as well. I have to check the rank of AB as well, right? So basically it can either be, let me copy this, paste this over here and paste this over here. It can be infinite solution, and it can be what do you say, a no solution. It can be no solution as well. Okay, so no solution and infinite solution. So this is the summary part. Basically you can the conclusion part. Okay, so yeah, there can be two sets of solution. One is inconsistent because there is no solution, that's why it is known as inconsistent set of linear equations. It is told as consistent set of linear equations because there are valid solutions, but there are two cases in the consistent portion. So one is rank of A equals rank of AB equals number of unknown variables, and one is less than it. So if it is less, infinite. If it is equal, it is unique solution. Inconsistent, basically these two are not equal, then it is inconsistent, then there is no solution. Okay, so yeah, basically this is how you basically learn this. So basically now you can do this question. Okay, I'll solve this question, I will come back, I'll just drink a bit of water. You try to solve this question. You have to solve the system of equations for the three cases: unique solution, no solution, and solution of infinite no solution and infinite solution. Solve the system of equation and find value of beta, basically. So I have to say that find value of beta, find value of beta. Okay, find value of it. Okay, you do this, pause the video, and I will just come back after drinking a bit of water. Okay, so let's start this question. So basically let me do the matrix mapping. So basically I will use the same the most used mapping, basically this one, right? So we use this mapping only. Okay, don't get confused by this mapping. We generally don't use this because why? As I told, right, this is taking up more width, right? More width. This is taking up lesser width. Okay, because these are all like in this column format, not in row format. So that's why we generally prefer to use this matrix mapping. So we'll use this only. So basically let me do this. So this is what I can do is I can simply copy this thing. So this will be okay, this will be 1, this will be 2, this will be 1, this will be 3, this will be 2, this will be 2, this will be x3. So now x5 is here, right? So there is a gap over here, so this will all be on the right hand side. This x4, so this will be 0 only. Okay, and this is 1 actually, -1, and this is 1. Okay, and this is 3, this is 4, this is 1 again. On the right hand side, this is the augmented matrix, right? So let me rearrange these things. Augmented matrix, and this is -1, fine. So I can just remove the positive signs over here. I can rearrange them. x3, this is 1, this is -1. Okay, so yeah, this is basically the augmented matrix AB. So I can reduce the size of this. Everything is recording, right? I have to recheck it 1 second. Yeah, this is recording. Yeah. So augmented matrix AB is this. Okay, now we can convert this into row echelon format. So basically what do we have to find? We have to find unique, no solution, and infinite. So if I easily convert this into row echelon format, it will be easier for us to understand, because this is 4x4, we can't use any other method, right? So I will try to convert this into row echelon. So for converting into row echelon, obviously I can see this is 1, right? So I will try to make all this 0. So what I will change? I will change row 2 to row 2 minus 2 row 1. I will change row 3 to row 3 plus row 1. I will change row 4 to row 4 minus 3 row 1. Okay, so this is the case. So yeah, let's write the converted versions. So everything will actually change over here. So what I will do is I will just pause the video. I will convert everything into row echelon format, and then I will come back, because that will just waste our time, right? Yeah, so I have basically converted into row echelon format the augmented matrix. So here, if you observe, like what I have done, what operations I have done. This one I have already told, right? I try to make all these elements 0. The first column of all the rows except the first row I made 0. Okay, these are also become 0, but I can see that this is not 0, right? So what I can do, I can, if I add these two rows and I add these to here, this will also become 0. So I have exactly done that, row 4 plus row 3, but this has become 6 and 3. But what I observe is the multiple of 3 is this, right? 3 times this is this. So if I do 3r2 and r4 minus 3r2, this will be 0. Okay, and this will be 0 to 1. Now what I can do, I can simply swap these two, right? I can also swap these two. I've forgotten to swap these two. So what I will do is just copy this thing, because we have to convert this into row echelon format, right? So basically I will swap the r2 and r3. Swap the r2 and r3. Swap this. Okay, I can cut this and I will paste this over here and this one over here. Yeah, so this is fine, right? So this is in the row echelon format. So now what are the 3 cases over here? So now if I want unique solution, what does need to happen? Basically the rank has to be equals to the rank of the augmented matrix has to be equals to the rank of the coefficient matrix equals to the number of variables. But is it possible by just seeing this here, right? I have 5 unknowns and I have 4 equations. Is it ever possible to get a unique solution? No. Okay, so just by observing this set of equations, I can say that I will never have unique solution. But let's say in terms of rank. Okay, so here what is the rank? What can the maximum value of this augmented matrix rank can be? It can be 4, because the columns here is 6 but the rows here is 4. So at max it can be 4. So if rank is 4 but number of unknowns is 5, obviously it is not equal to the number of unknowns, it is less than number of unknowns, then definitely there can't be any unique solution. There can't be any unique solution. Okay, so unique solution is out of the window. Okay, rank of AB equals to rank of A equals to number of unknowns is out of the window. So not possible. Not possible. Now let's think about no solution. So for no solution, the condition I've already written, the rank of AB should be greater than the rank of A. The coefficient matrix should have lower rank than the augmented matrix. So is it possible? So there is no boundation in the number of unknowns here. No boundation in the number of unknowns. They are just talking about the augmented and the coefficient matrix. So basically I can see I have a row of 0 over here, and this, if this is not 0, then the rank of the whole augmented matrix is still 4, because this is a row of not 0. So the number of non-zero rows are known as the rank. So here the number of non-zero rows for the augmented matrix is 4 if this is not equal to 0. Now this is 0, right? But the number of non-zero rows of the coefficient matrix is what? 1, 2, 3, because this is always 0. There is no condition. This is always all 0. So what can happen is only one condition has to satisfy, that this has to be equals to 4. So beta plus 1 can't be equal to 0. This element can't go to 0. Okay, this has to be non-zero. So if this is non-zero, then so this is not equal to 0. So the beta will be not equals to minus 1. So if beta is not equals to minus 1, it can take in any value except minus 1. Except minus 1, you put any value of beta, there will always be the case of no solution. Okay, now let's come to the third case. So where I have infinite number of solutions. So if I have infinite number of solutions, what does that mean? That means the both ranks, augmented matrix rank and the coefficient matrix rank, should be equal. Okay, it should be less than number of unknowns. Okay, anyways it is less than number of unknowns, but the augmented and the coefficient matrix rank should be equal. So for that, what condition needs to be satisfied? So here, what is rank? Rank is the number of non-zero rows in the row echelon format. Okay, or you can say linearly independent or dependent, but like let's do it using this way because it is easier for us to understand. So if I take the augmented matrix, the number of non-zero rows, if I want 3, because the coefficient matrix has 3 non-zero rows. So if I want 3 non-zero rows in the augmented matrix also, then this has to go to 0. If this is going to 0, then this whole row will be again 0. So beta plus 1 equals to 0. Beta plus 1 equals to 0. So beta equals to minus 1. Beta equals to minus 1. So this is the case for infinite solution. Okay. Now let's talk about the nullity. So this has been solved, right? So the question has asked for the find the values of beta for unique no solution and infinite solution. The question has been solved. Now let's discuss about nullity. So if I put beta equals to minus 1, then what will this like matrix mapping become? If I put beta equals to minus 1, this will also go to 0, right? This will also go to 0. Okay. Now can you say anything about the nullity here? Can you say anything about the nullity? So what is nullity? Nullity. So if I talk nullity about here, anyways there is no solution. So is we won't obviously talk about it here because there is no solution in this case. But if you want to talk here, the rank of A is 3 inverse. Rank of A is 3 inverse. Okay, and total number of variables is 5. So here the nullity will be 2. Nullity will be 2 here. Total number of variables is 5 and rank of A is 3, so nullity will be 2. But for no solution, we don't talk about it. We mainly talk about it in the infinite solution case. So for the infinite solution case, the rank of A is 3, right? Rank of A is 3. Okay, and rank of AB is also 3. But let's talk about the nullity. So if I talk about the nullity, it will total number of variables. Total number of variables is 5. Up to x5 we have, and minus rank of A, which is 3, rank of coefficient matrix, so which is equals to 2. So we have two free variables. So we have two variables. Are there really two variables? Let's see, right? So my coefficient matrix is this. Okay, so if I write this like this, so here, right, this is x1, x2, x3, x4 and x5. Okay, so now I have just swapped these two, if I remember. Yeah, these are right. So yeah, so basically I can write this, right? This whole equation is 0. So this x5 times 0 equals to 0 always. Okay, so obviously my x5 can be anything. Okay, always true. This is always true. Why haven't I chosen x4? I will say just in a second. Okay, always true, because I can see there is a relation in x4, right? That's why. So now, so I can assume my x5 as, let's say, alpha 5. x5 is some alpha 5. Now let's solve this equation. So in this equation it is stating that 2x4 plus x5 equals to 0. So my x4 will be equals to minus alpha 5 divided by 2. Okay, minus alpha 5 by 2. Now let's solve this equation. So if I solve this equation, what do I see? I see that x3 plus 2x4 plus 5x5 5x5 equals to 4. So basically x5 and x4 I know, I can put the values. X5 is alpha 5 only, so it is 5 alpha 5, and 2x4 is what? It is minus alpha 5. So minus alpha 5, and x3 is here, which is equals to 4. So my x3 will be simply 4 plus alpha 5 minus, okay, no, this is only same thing only. So this is minus 4 alpha 5, right? So I can take the 4 common, 1 minus alpha 5. Okay, so my x3 is 1 minus alpha 5. Now is there any boundation on x2 here? Okay, is there any boundation x2 here? There isn't. We will solve this, then we will understand. Because here, right, I will need the value of x2 as well. I will need the value of x2 as well to find the value of x1. Okay, because all these values I know, x2, x3, x4, x5 I know, but I don't know x2. If I don't know x2, so I have one equation and two unknown variables. Okay, so to find the value of x2, I have to assume that x2 is some alpha 2. Okay, so assume x2 is some alpha 2. Now, so putting it in the first equation, so obviously x1 plus x2, let me just write down the equation. Sorry, this is 2x2 actually. Minus x3 minus x4 plus x5 equals to 1. So basically I know x3, x4, x5, all these things know. x2 is also alpha 2 right now. x2 is also alpha 2. So x1 will be equals to what? X1 will be equals to 2x2. x2 is alpha 2. So this is 1 here, 1 at the starting, then minus 2 alpha 2, then x3 plus x4. So x3 is this 4 into 1 minus alpha 5, and x4 is what? x4 is which I believe is minus alpha 5 by 2, minus alpha 5 by 2, and x5 is what? x5 is basically alpha 5, right? We are choosing alpha 5. So plus, this is also, or this is plus, right? No, this is minus actually. This will go up there, minus. So this will be minus up there, alpha 5. Okay, so I can write x1 equals to this is 5 actually, and minus 2 alpha 2, and this is minus 4 alpha 5, and this is minus 5 alpha 5 minus, so this will be minus 5.5 alpha 5. Okay, so basically this is what we get. Let me check if I am making any mistakes or not. So just hold on a second. Minus 1 minus 2 x3. Okay, this is minus 2 x3. Sorry, I was just thinking that I must have made, like, because I make too many silly mistakes in exams also. That happens to me. So this is minus 2 x3, so this will be 2 only, so this will be 8, right? This will become 8. So this becomes 8, this will become 9, and this is minus 8 alpha 5. So extra 4 will get added, so this will become wait a second, not extra 4. So this is minus 8 alpha 5, and this is, okay, just hold on a second, this will be 9.5 alpha 5, right? So yeah, this is minus 9.5 alpha 5. Now if I write this in our solutions in the column format, so if I want to write the solution x in the column format, what do I see? So basically what you can observe is these, right, all these x1, then this x3, then this x4, these three variables are dependent, and x5 is anything, alpha 5 is any value, any real value, okay, any value I can choose, and x2 also, alpha 2 is any value I can choose, okay. So basically two free variables, and from the nullity also we found out that nullity is 2, hence two free variables will be there. So this is just to basically prove you that how many free variables are we getting, how many free variables are we getting. So if I write this solution, right, in our column format, x4, x5, okay, this is also known as vector, okay. In next after the solution of homogeneous equations, we will learn about eigenvectors, eigenvalues. This is also known as column vector. So like a column matrix is also known as a vector, okay. So now what is the solution for x1? For x1 it is simply written 9 and okay. Now what I am talking about is, so not not about x1 but this x, right, this solution can be broken down into two parts. One is the homogeneous part and another one is the non-homogeneous part. Basically one is the where it is dependent, one is a particular solution, another one is the infinite solution. So let's see that. So I will just write this down, then I will explain it to you. So this is 0, and like whatever, whichever are not present with alpha, I will write those here, okay, and I will write as a summation of 2. So this is 0, this is also what, this is 4, right, x3 is 4, x3 is 4 here, x4 has only alpha, so I won't be able to write anything, I will write 0 over here, and x5 also has alpha, so I will be able to write, I will add this with another solution. What is the other solution? This is alpha 2, wherever alpha 2 is present I will write this here. So alpha 2 is present in this x1, so minus 2, the coefficient of alpha 2 is minus 2. In x2 it is directly alpha 2 itself, so it is equals to 1, coefficient of alpha 2 is 1, and x3, x4 and x5 don't have any alpha 2 present, okay, so this will be 0. Now let's write the alpha 5 terms. So if I write the alpha 5 terms, so basically alpha 5, does x1 has alpha 5? Yes, it has 9.5, coefficient is 9.5. Does x2 has alpha 5? x2 don't have alpha 5. x3 has alpha 5, which is minus 4, and x4 has alpha 5, which is minus 0.5, and obviously x5 has alpha 5, which is equals to 1 itself, right? Basically coefficient of alpha 5 is 1 for x5 equals to alpha 5 itself. So what do you observe? If I just cut this and take it to the next page, the thing that we observe is that it is a summation of two solutions. So basically what I was telling, that this, right, if I put these values, this is also a solution, this is a particular solution. If I put all these values of x1, x5 and x3, x2, all this value, right, this is satisfied. So basically x1 is 9, x2 is 0, x3 is 4, x4 is 0, x5 is 0. So let us put all this, right, in these equations. So if I put over here, what was the, okay, let me just copy this and just show you, okay. If I just copy this, I'll just copy and show it to you, that if I put all these equations, right, so here, now you put, right, you put x1 equals to 9 and all this 0, 0, 0. So this is 0, this is gone, this is 0, this is gone, this is gone, this is 4, right? So this is minus 2 into 4, which is minus 8, and 9 minus 8 is 1, satisfying. Again you use this, okay, use this equation. So this is 18, this is gone, 0, this is minus 16, okay, 4 into 4 is 16, 18 minus 16 is 2, this is gone, 0, so it is 2. So you satisfy all this equation, this equation will satisfy, but this is a particular solution, because these are the particular values of the variables. Okay, now let's take the other part, right, this homogeneous part. Now if I take this other part, this is known as the like null space. So we'll talk about this later also, null space, we'll talk about this later. But what is the advantage of this? So basically if I use this equation, right, if I use this equation, okay, put these values over here. So basically if I put like this in x1, x2, x3, what we'll get? We'll get a homogeneous equation. As I told, right, homogeneous equation means the right hand side will be 0. So it won't matter, it won't like change anything to the equations. That's why these are known as a null space, because those are the particular solutions the values of those are fixed. Okay, now whatever values I put over here, it doesn't matter because it doesn't change my final solution or final this equation. Okay, this equation is still valid if I put these values. Okay, because this is only giving me right hand side 0 and 1 plus 0 is 0, 1 itself, so it doesn't matter, it is not changing anything. That's why this is known as infinite solutions, because whatever values of alpha 2 I pick, it is not changing these equations. Okay, that's why. So let us take one example. If I take here alpha 2 into minus 2, so x1 is minus 2 alpha 2 and x2 is alpha 2 only, right? X2 is alpha 2 only, others are 0. So plus 2 alpha 2. So this is equals to 0 itself. So whatever value of alpha 2 I pick, it doesn't matter. It is always equals to 0. So it is not contributing to anything. Okay, it is not contributing to anything. But I'm free to choose x2 anything. I'm free to choose x2 anything. That is what this basically means. Now again, let's use this, right? Let's use this. Basically here, this is minus 9.5. Now I can cross check whether I have done this correct or not. So this is minus 9.5 alpha 5, right? Now x2 is 0, so this is 0, and x3 is minus 4 alpha 5, so this is plus 8 alpha 5. X4 is minus 0.5 alpha by 2, so this is plus 0.5 alpha by 2, alpha 5, and this is plus alpha 5. Yeah, we have done this correct only, plus alpha 5. Okay, this is equals to 0 itself. You can observe that this is equals to 0 itself, right? So if these are cancel each other out, so this is 9.5 alpha 5 and this is 12, so it equals to 0. So again, this is also not affecting. So these two, right, these two vectors are not affecting anything. I am free to choose x5 anything, it won't change the solutions over here of other variables. Okay, that's why they are known as free variables, and that's why they are important. Okay, that's why finding the homogeneous equations, solution of the homogeneous equations are also important. So basically this is, where did it go, this is known as a particular solution. Okay, and these are known as a complementary solution. Okay, in differential equation, you know, complementary solution, because they won't do anything. These are known as a homogeneous equation also. Okay, complementary solution. So basically this is known as xp and this is known as xh. Our x, okay, final solution x will be summation of xp plus xh. Now what is the interesting fact over here is, if I multiply a on both sides, okay, a matrix, so a times x will be equals to a times xp plus xh. Now this will be a times x equals to a times xp. So a times xp is something non-zero, which is equals to the constant term, right? Constant b term, which is equals to the constant b term. So this it is equals to b plus null matrix, because I just prove it to you. Whenever I put xh, it becomes null. Everything becomes 0. So this is known as the, we'll study about this later. Okay, we'll study about this later. But for now, this is known as the null space, because everything is becoming null. Okay, so this is the basically case. So basically I will write in brackets over here that a into xp equals to b and a into x is equals to 0. Okay, so yeah, I hope you got the point over here. So basically this is the combination of two solutions. Okay, so basically I have also written the points over here. Solution of non-homogeneous linear system are of form of x equals to xp plus xh. Okay, where xp is any fixed solution, particular solution of xh equals to b, and xh runs through all the solutions corresponding to the homogeneous equation. Because for a homogeneous equation, we'll we'll only either get infinite solution or zero solution. We'll see that. Okay, so that's why it is telling us it runs through all the corresponding solutions, because we have two free variables and the free variables are free to take any values. So hence we get infinite number of solutions over there. Okay, like what do you mean by this? So I can pick this alpha 5 and alpha to anything, and that will change my x1, x2, x3. Okay, if I pick alpha 2 and alpha 5 as 0, my x1, x2, all these variables are fixed. If I do pick alpha 2 equals to 1, alpha 5 equals to 5, then my this variables will change, right? If I pick alpha 2 equals to minus 5, alpha 5 equals to minus 0.5, then this will change. So I can pick anything and still my variables will change. I can get infinite number of solutions, okay, due to these two combinations, okay. But these two combinations aren't actually doing anything. These two are actually contributing 0, as we saw in the example and from here also, okay. That's why whatever value of x1, x2, x2 is, there are infinite number of values due to these two, but these two aren't doing anything. These two are just homogeneous equations, okay. So yeah, that is what we see over here. So that is what this key point has told us. Here, free variables are responsible for infinitely many solutions. As I told, right, we have two free variables which are responsible for infinitely many solutions, okay. And an invertible matrix has no free variables. Why? Because like obviously it is a full rank matrix, so nullity will be 0. That is first key thing. And obviously if the matrix is invertible, that means ax equals to b, and I can take the inverse, so x equals to a inverse b. Now obviously this will be some particular value, which will get a particular solution, okay. So this, from this we will get a particular solution. So basically these were the few key points. Now let's do this question. This question is telling us find the nature of solutions for system of equation. For the system of equation, we have to find the nature of solution. Obviously we see that we have 4 unknowns and 2 equations. Obviously unique solution is not possible from the start itself. Now let me write this in the augmented format. 2 4 1 2 minus 1 minus 2 3 6. I can directly see that this is like row 2 is directly proportional to the row 1. That is basically row 2 is equals to simply 2 times row 1, right? Row 2 is simply equals to 2 times row 1. So row 2 is equal to 2 times row 1. So basically like you can convert this matrix, write the equivalent matrix, okay. Basically I can do this operation. Row 2 is changed to row 2 minus 2 row 1. So basically 2 1 minus 1 3, this is 0 0 0, and this is everything 0. So basically what do we observe over here? We observe that rank of augmented matrix and rank of the coefficient matrix are same, which is equals to the 1, and which is less than the number of, obviously number of unknowns is less anyway, so we will get infinite number of solutions. Number of unknowns is anyways left. We already knew that unique solution is obviously not possible, so that was out of the window. Either we get infinite solutions or no solution. We get infinite solution, okay. So if you get infinite solution, what is the nullity over here? How many free variables we have? So the rank is 4, number of unknowns is 4, sorry, rank is 1, number of unknowns is 4. So nullity will be number of unknowns minus rank of A, which is equals to 4 minus 1, which is equals to 3. So 3 variables I have to pick. 3 are free variables. Basically why? Because this, right, here I can pick anything, right? This x1 x2 x3 anything, they will be always equals to 0. Now here if I pick, like if I don't know this value, then I will obviously not be able to solve this equation. I need three variables from this, right, to solve this one equation. Basically 3 of them should be known and 1 of them should be unknown. Then I will write this particular thing with respect to these 3, right? So obviously I have to pick alpha 5, alpha 4, sorry, this alpha 4, alpha 3, alpha 2. So with the help of this I will be able to write. So basically nullity is 3, the number of free variables is 3, hence I will choose 3 free variables. X2 equals to alpha 2, x3 equals to alpha 3, x4 equals to alpha 4. Now if I put these things in the first equation, so x1 2x1 plus x2 minus x3 plus 3x4 equals to 3. So x1 equals to 3 minus x2 is alpha 2 plus x3 plus alpha 3 and minus 3x4, so minus 3 alpha 4, okay, and x1 equals to 3 by 2 minus this whatever this is, right? So this is alpha 2 by 2 plus alpha 3 by 2 minus 3 alpha 4 by 2. So this x1 I can write in terms of this other 3 variables. So these 3 variables are free to choose anything, okay, but other than that this I have to obviously decide, right? This I have to decide. So if I choose alpha 2, alpha 3, alpha 4 equals 0, then what do you see? X1 equals 3 by 2. So if all of these are 0, then x1 if I put 3 by 2, then obviously this equation is satisfying. 3 by 2 is 3 itself, so this is satisfying. Okay, like that you can see that if I put this 0, then it is satisfying. That is a particular solution. So this is again a xp. So this, right, this is simply xp, and these are simply xh. So if you put all this, right, you will see you will getting 0, you will getting a homogeneous equation. So like this is just a summary. If the number of equations is greater than number of variables, okay, this is important factor. If the number of equations is greater than number of variables, then there can be no solution, infinite solution, and unique solution, because rank can be still equal to the number of variables. Okay, then it can be unique solution. Rank can be still equal to number of variables, or rank can be less than the number of variables. Okay, so rank can be equal and less. So hence we are getting 3 like possibilities. Now if number of equation is less than the number of variables, we have only 2 possibilities, because rank of AB can rank of A can never be equals to number of variables, because rank of A can never be equals to number of variables. Hence determinant of A will be equals to 0. And if determinant of A equals to 0, what do you know? For determinant of A not equals to 0, we know we get unique solution. But for determinant of A equals to 0, like this, we're talking about the non-homogeneous equation. Just remember, this we're talking about the non-homogeneous equation. For non-homogeneous equation, determinant of A equals to 0, that means I will either have no solution or infinite solution. I've just already done that in the summary part, right? Already told you in the summary part. Okay, so here they are talking about determine the value of beta if nullity of A is 1. Nullity is 1. So if nullity is 1, what is the rank? So number of unknowns is how much? 3. So 3 minus rank is 1, nullity. So basically this has 2 methods to solve. First we will solve with the row echelon format, and then we will solve with the what do you say, determinant format, right? So here if nullity is 1, that means what is the formula of nullity? Nullity of A equals to number of unknowns minus rank of A. Okay, so rank of A equals to nullity minus number of unknowns. So number of unknowns is 3 minus nullity is 1, so rank of A is 2. So rank of A is 2, that means we have 2 independent rows or columns. We have one dependent row. Okay, so we have one dependent row. So we have one dependent row, one linearly dependent row or column, whatever you want to say, you can say. Okay, so basically what I can see is these two are matching. Okay, these two are matching. If I multiply minus 1 with this is minus 1, these are equal. If I multiply minus 1 with this minus 2 and minus 2 are equal. But these are we don't know. Okay, so if I make these also, if I multiply minus 1 with this is minus beta, so this is 1. So minus beta has to be equals to 1. Minus beta has to be equals to 1. So beta will be equals to minus 1. Like this you can understand. Okay, like this you can understand. Or if you don't want to understand like this, what you can do is you can simply use a method 2, which is determinant. Now if you know nullity is 1, if you know rank is 2, which is less than the number of unknowns, that means like obviously it has either infinite solution or no solution. Okay, because rank of A is 2. Okay, so that means the determinant is 0. So simply use the determinant formula. Determinant has to 0. Rank of A is less than 2, hence determinant should not less than 2, less than 3. It is not a full rank matrix, hence determinant of A is 0. Okay, determinant of A is 0. So just use that equation. 3 2 1 beta 1 2 1 minus 1 and minus 2. So I have to make maximum number of zeros. So what I will do, I will just add these two row, right? Just add these two row. So basically I will change R2 to R2 plus R1. So if I change R2 to R2 plus R1, this will be 3 to 1. This will be beta plus 1, this will be 0 0. Okay, this will be 1 minus 1 minus 2 equals to 0. So basically I can open along this row. If I open along this row, this is plus minus plus, and this is minus plus minus, or you can say plus, this is minus. So we'll open with minus, it doesn't matter because anyways it is equals to 0 itself. Beta plus 1, and we'll just block these row and column. So 2 times minus 2, which is minus 4 plus 1, so which is minus 4 plus 1, which is minus 3 equals to 0. So this is non-zero, so we can divide it with this. So beta plus 1 has to be equals to 0. So beta equals to minus 1. Okay, so beta equals to minus 1. Okay, so yeah, like this you can solve. Whichever way you find suitable, you can solve. Now let's solve this next question. So for what values of alpha and beta the system of equation will become consistent? What do you mean by consistent? Consistent means either infinite solution, at least it has some solution, right? No solution is not possible. That means inconsistent. So if it is consistent, that means either it has infinite solution or unique solution. So basically what can be the case? We have to use a row echelon format, right? Again we have to convert this into simple matrix mapping. Okay, so basically A be the augmented matrix equals to, let us write the coefficients, 1 minus 1 1, 1 minus 1 1, and this is 2, this is 1 2 3, this is beta, this is 3 3 alpha, 3 3 alpha, and this is 1. Okay, and so basically what we'll do, we'll just simply use a row echelon format. So I can simply multiply 3 times this. I will just not write them again. So I will just not write the operations because that will just waste our time. So I hope you understand, right? So this is, I will subtract row 2, I will subtract row 1 from row 2. So this will be 0, this will be 3, this will be 2, this will be beta minus 2, and I will subtract 3 row 1 from row 3. So this is 0, this is 6 3, so this is alpha minus 3, and this is so this is minus 5, right? This is minus 5. So yeah, this is the equation that I get. Now I have to obviously get a 0 over here. So I will subtract 2 row 2 from row 3. So again, right, I will just copy this thing. So this will become 0, and I'm subtracting 2, right? So this will become 7, and if I subtracting 2, so this will become, we have to add like minus 1 and minus 2 beta. Okay, so yeah, this is what this becomes. So now from here, what are the cases? I need consistent solution. So for consistent solution I have two options. Consistent solution, I have two options. So either I will get infinite solutions, okay, or unique. Consistent means at least I will get some solution I will get. So infinite solution or unique solution. Okay, so for infinite, what is the case? Basically the rank of AB has to be equal, but it has to be less than the number of unknowns. So my number of unknowns is 3, so obviously the rank has to be equals to 2. So this has to be equal to 0 for the rank equals to 2, and this also has to be equal to 0 because these whole row has to become 0 because the rank of augmented matrix and the coefficient matrix has to be same. So obviously in this case, what we'll do, alpha minus 7 equals to 0 and minus 1 minus 2 beta equals to 0. So alpha equals to 7 and beta equals to minus 1 by 2. So for infinite solution, this is also consistent. Okay, now for unique solution, the rank has to be equals to 3, rank has to be equals to 3. Basically rank of A has to be equals to the rank of A of AB, basically augmented matrix, equals to the number of unknowns, which is equal to 3 in this case, x1 x2 and x3. So this can't be equal to 0, and obviously this also can't be equal to 0, but okay, sorry, this can be equal to 0, this can be equal to 0 because this can be any value, only the main condition is in this case, right? Because if this is equals to 0, then this goes to rank 2, which is not possible. This rank of the coefficient matrix has to be equals to 3. Okay, but if this is not equal to 0, then anyways the augmented matrix has also rank 3, because even if this goes to 0, this is non-zero. So this is whole row, right? This whole row is non-zero. This is still in the row echelon format. And how many non-zero rows I have? If this is not equal to 0, I have 3 non-zero rows. What do I mean by that? So let's say alpha is 8. If alpha is 8 and beta is minus 1 by 2. So if beta is minus 1 by 2, this goes to 0. Let me just do one example. Okay, let me just do one example. Like alpha 8 and beta is minus 1 by 2. So if beta is minus 1 by 2, this one goes to 0. and this is 1, right? This is 1. Okay, so this is still in the rotational format, right? Because again this is staircase, nothing wrong with that, right? These are the pivot columns. Okay, like these are the pivots basically. So these are non-zero. So here number of non-zero rows is 3. So rank of A equals to rank of AB equals to 3. Okay, so only condition is in beta, so sorry, is in alpha. So alpha can't be equals to, in this case alpha can't be equals to, alpha minus 7 can't be equals to 0, that is alpha can't be equals to 7. Okay, beta anything, beta can be anything, right? Beta belongs to anything, right? Beta can be anything, but alpha cannot be equal to 7 for unique solution. So let's check out the options. So alpha equal to 7, beta equals to half. Is this true? So alpha equals to 7 for consistent state of solution, alpha equals to 7 and beta equals to minus half. No, beta has to be equals to minus half, right? So again this is not true. Now alpha equals to 7 and beta equals to minus half. This is true because here alpha equals to 7 and beta equals to minus half. So this is a consistent set of solution. So this is true. Now alpha not equals to minus 7 and beta not equals to minus half. So if alpha is not equals to minus 7, alpha is not equal to what? Minus 7 is written over. Oh, minus 7. Okay. Then beta is not equals to minus half. Beta is not equals to minus half. So alpha can be 7 over here. If alpha is 7, then again this is not valid, right? This is not valid. If alpha is 7, this is not valid. Because if alpha becomes 7, then wait a second. So if alpha becomes 7, beta has to be equals to minus 1 by 2, and it has told that beta cannot be equals to beta cannot be equals to minus 1. So if this case fails, right? So for this case to fail, basically let's say take one example. So here it is saying alpha not equal to minus 1. Fine, alpha is not equal to minus 1. Let's take one example that alpha is equals to 7. Now if alpha equals 7 and beta has to be equals to minus 1 by 2 for it to have infinite solution, okay, for alpha equals to 7. But here it is telling that beta is not equals to minus half, so obviously not possible the solution. Now alpha is not equal to 7, beta is not equals to minus half. So alpha is not equal to 7, beta is not equal to minus half. Basically alpha not equal to 7, beta can be any value. Beta can be any value. Just hold on a second. Okay, sorry. Yeah, this is okay, fine. This is fine. Now here it is showing me alpha not equal to 7. Okay, alpha not equal to 7. If alpha is not equal to 7, beta can be anything. So there is no condition. So anyways, beta can be anything. Here it has told beta is not equal to minus half. That is fine. That is fine anyways. So beta can be anything. Beta anything. Okay. So basically this is correct also. If alpha is not equal to 7, beta can be anything. There is no boundation in the value of beta. Okay. So now let's go for the next question. So here we have to find the nature of solution for the system of linear equation if A is a non-singular matrix. So if A is a non-singular matrix, what do you do? If A is a non-singular matrix, basically it's talking about the coefficient matrix where A is the coefficient matrix. So if A is a non-singular matrix, that means basically it can only have unique solution. If A is non-singular, it can only have unique solution. So A is non-singular, A non-singular, then what can I derive from this? Determinant of A cannot be equal to 0. Now if determinant of A is not equal to 0 for non-homogeneous, that means we have unique solutions. Okay, pretty simple, right? Pretty straightforward, pretty simple. Or you can do from the rank concept itself, because rank will be 3, because this, right, this is non-singular, so full rank matrix, so this is 3 rank. From there also you can understand. So yeah, let's solve this last question. This is a very good question, came from GATE 2003 CSE paper. So we have to consider the following system of linear equations, and notice that the second and third columns of the coefficient matrix are linearly dependent. Second and the third column, yes. If I multiply second column with -4, this will become exactly equal to the third column. Now for how many values of alpha does this system of equations have infinitely many solutions? For how many? Okay, they are not asking us the value of alpha, they are asking how many. That is very important point to note here. So whenever you are solving questions, just see that what are they asking us. Are they asking us the value of alpha, or for how many values of alpha? That is also very important. So let me write this matrix up. Okay, let me write the augmented matrix. this is equals to 2 4 1, this is equals to 1 3 2, this is equals to minus 4 minus 2 1 minus 8, and this is equals to alpha 5 and 7. Okay, this is alpha 5 and 7. Now can I convert it into row echelon format? So if I want to convert it into row echelon format, first I want 1 at this point, right? 1 at this point. So I will just interchange my rows. So this will be over here and this will be over here, right? So now what else I do? Basically now I can simply use row operations, right, to make this element 0. So if I make this element 0, this will 0 4 times subtracting this, so this is minus 3, this is 2 times subtracting this, so this is 16, this will be 12, and I am subtracting 4 times this, so this is minus 5, 4 times 32, so this is plus 20, and this is like still same minus 8 only. Okay, and this is 7 alpha minus, I am subtracting 2 times alpha minus 14, and this is subtracting 4 times, so 5 minus 28, which is minus 23. Okay, so yeah, now I have to make this one also 0, right, to convert it fully into the row echelon format. So yeah, let's further solve this. So this is 1 2 minus 8, and this is 7 alpha minus 14 minus 23. Okay, and this is basically 0 minus 3, 0 minus 3 minus 12, sorry, not minus 12, this is plus 12, and basically this is like what would I do? I will just multiply 5 over 3 and then subtract these two up, right? So multiply 5 over 3 in this row 2 and subtract these one up, so this will go to 0. So if I multiply 5 over 3, so what will this become? 5 over 3, this will become 20. If I subtract 20 with this will also become 0. So this will overall become a row of 0. And 5 over 3, if I multiply, this will become minus 5 over 3 alpha and plus subtracting, right? So this is plus 5 over 3, basically 80 over 3, right? So basically what do you want in the question? In the question they are talking about infinitely many solutions. So for infinitely many solutions, this has to be equals to 0. This has to be equals to 0. So I will get overall rank of A is obviously less than a number of variables. That is good. But rank of AB has to be equal to rank of A. Then only we will get infinitely many solutions. So here obviously rank of A equals to rank of AB equals to 2. So if it is equal to 2, then minus 23 minus 5 by 3 alpha plus 80 by 3 equals to 0. So obviously if I multiply 3 on both sides, so this will be 5 alpha, this will be 80. Okay, sorry, I made a mistake. Sorry, this will not be 80, this will be 70. This will be 70. Last question only. Yeah, sorry, actually the power has been gone. Just I just want to say that this is basically 1 by 5. Okay, alpha is 1 by 5, but they are not asking about the value of alpha. So I don't have light right now, so just bear with me for just one. This is the end of the lecture basically, so I don't want to again restart everything. So basically we have only single value of alpha and it is equal to 1 by 5. So if their option is 1 by 5, don't put that. Okay, they are asking how many values, so only for a single value of alpha we're getting infinite number of solutions. So obviously our answer is B, right? Our answer is B. So this is the answer of this question. Okay, I'm sorry, apologies for the quality because the light has went off. Bangalore, like, I don't know, like the light went off, goes off very frequently, very frequently. Okay, so yeah, this is the solution of this question. So basically, I hope you got to the point. I will try to summarize this lecture quickly, and then I will start the solution of homogeneous equation. So yeah, thank you for watching, and I will see you in the next lecture.